Hello, today I am going to present a scientific biography of Niels Bohr, focusing on his contributions to quantum mechanics and their impact on modern physics. Niels Bohr was a Danish physicist born in 1885 and one of the founders of quantum mechanics. His work not only transformed atomic theory, but also changed the philosophical foundations of physics, moving from a determinist to a probabilistic understanding of nature. Bohr completed his PhD in 1911, studying the electron theory of metals. During this period, he identified serious limitations in classical physics, especially when applied to microscopic systems. This problem became the starting point for his later work in atomic theory. Bohr is considered a transitional figure because he introduced quantum concepts into classical models. Classical physics assumed continuity and determinism, but Bohr proposed that atomic systems behave in a discontinuous and quantized way. This shift represents a fundamental change in how we understand physical reality. In 1913, Bohr combined Rutherford's nuclear model with Planck's quantum hypothesis. He proposed that electrons occupy discrete energy levels defined by quantized angular momentum. Radiation is emitted or absorbed only when an electron transitions between these levels, not while it remains in a stable orbit. Quantization significance. The quantization of angular momentum has both physical and mathematical significance. It explains atomic stability since electrons do not con- contin- continuously lose energy. It also allows precise predictions of spectral lines, connecting theory with experimental results. This idea became a cornerstone of quantum mechanics. Bohr's model successfully explains the hydrogen atom because it is a simple system with one electron. However, it fails for more complex atoms due to electron-electron interactions. This limitation showed a more complete theoretical framework was needed, leading to the development of modern quantum mechanics. Bohr's principle of complementarity is both a physical and epi- epistemological concept. It states that quantum systems require different mutually exclusive descriptions, such as wave and particle models. These descriptions cannot be applied simultaneously, but both are necessary for a complete understanding. This implies that knowledge in quantum physics is fundamentally limit, limited by experimental conditions. Debate with Einstein. Bohr's debates with Einstein were central to the interpretation of quantum mechanics. Einstein criticized the theory for its indeterminacy, arguing that it was incomplete. Bohr responded by defending the internal consistency of quantum mechanics and emphasizing the role of measurement. These debates clarified the conceptual foundations of the theory. For Bohr, experimental conditions are essential in defining physical reality. The outcome of a quantum experiment depends on how the system is measured. This means that the properties are not independent of observation, which challenges classical objectivity. Liquid drop model. In nuclear physics, Bohr developed the liquid drop model with John Wheeler. This model describes the nucleus as a collective system similar to a drop of liquid. It explains nuclear fission as a process where the nucleus deforms and splits, releasing energy. This was fundamental for understanding nuclear reactions. Scientific ethics. During World War II, Bohr contributed to the Manhattan Project. However, he later became deeply concerned about the ethical implications of nuclear weapons. He proposed the idea of an open world, promoting transparency and international cooperation in scientific research. Influence today. Bohr's work continues to influence modern interpretations of quantum mechanics. Concept, Concepts like complementarity remain central in quantum theory and quantum information science. His ideas also shaped the philosophy of science by redefining, redefining the limits of knowledge. Conclusion. In conclusion, Niels Bohr was not only a physicist, but also a thinker who redefined the foundations of science. He introduced key concepts such as quantization and complementarity, and helped establish quantum mechanics as a coherent theory. His legacy continues to influence both science and our understanding of reality.